everyone. Hello Sir Yosef. We are from Group 1 of the Material Flow Analysis and Life Cycle Assessment course. We will present our final paper. The title is Addressing Efficiency and Environmental Impacts of Recycled Paper Production. Next, let me introduce our member from Group 1. There are Chit, Ivana Laura, Karina Dewi Nurrahma, Muhammad Arrasyid, Muchamad Rizqi. The last is Regina Gaghana. The first is introduction. The pulp and paper industry is a major contributor to global energy use and greenhouse gas emissions, accounting for 5.7 of industrial energy consumption and ranking as the fourth largest GHG emitter. It is also a leading cause of deforestation, especially in Indonesia. While paper is essential and widely used, its production relies on virgin pulp from trees and recycled pulp from newspaper. Recycled pulp offers a more sustainable option, reducing deforestation, conserving resources, and minimizing environmental impact. In China, the industry is one of the top 10 GHG emitters across 39 industrial sectors and account for 1.7% of industrial energy demand. It contributes 9% of industrial energy demand and 2.5% of overall energy-related GHG emission in Germany, but it makes up 5% of total final energy usage and 15% of industrial energy consumption throughout the European Economic Area. In addition to the production of GHG, the pulp and paper industry has long depended on wood. Environmental Paper Network has mentioned the deforestation is still mostly caused by pulp and paper sector, especially in Indonesia, where new data shows a worrying comeback of forest loss. According to Trace's special study, Borneo accounted for 98% of Indonesia's new deforestation in 2022, with the pulp industry alone removing 23,000 hectares or an area almost equal to Paris. In order to fit a new pulp mill that is being built in Tarakan, concessions controlled by business like Mayawana Persada in Central Kalimantan, Nusantara Fiber in Eastern Kalimantan, and Adindo in North Kalimantan are mostly to blame for this deforestation. The forests of Indonesia are seriously threatened by just one facility, which exacerbates environmental issues and highlight the need for sustainable alternative in the paper industry.
Okay, next is methodology. There are goals and scope. The goals is examine production process of recycled paper. This goals focus on understanding how recycled paper is produced, covering every stage from waste collection to the final product. And next is identify areas to improve the efficiency of materials and energy flow. This goes involve analyzing how resources like raw materials, energy, and water are used through to the production process. And the scope involve the entire life cycle of recycled paper from waste collection to the final product, wherein waste collection refers to gathering and transporting recyclable paper from various sources. And processing include sorting, cleaning, pulping, and transforming the paper into usable material. And for the final product, cover, packaging, and delivering the recycled paper to customer. And next is focus on reducing environmental impacts such as greenhouse gas emission, energy consumption, water usage. In greenhouse gas emission include emission generated during transportation and energy intensive production stage, and energy consumption focus on energy demanding process like drying and pulping with potential of renewable energy use, and water usage involves steps requiring large amounts of water, such as pulping and sheet formation, with emphasis on water recycling and treatment solution. And for the functional unit, 1 metric ton of recycled paper, a metric ton or 1,000 kilograms of recycled paper refers to the quantity of paper that has been collected, processed, and repurposed into newspaper product. This recycling amount of paper has significant environmental benefit, where the environmental benefit is energy saving.
Okay, next is system boundary. The system boundary for this study encompasses the six steps of recycled paper product. The six steps are crucial for transforming waste paper into new, usable, recycled paper. The system also accounts for the associated liquid and energy flow during usage, as well as the management liquid, was energy throughout the process according to the mass to balance the cycle paper 2 by Fabrina R. The overall purpose is to assess the energy and material fluxes and their environment impact across the stage in figure 1. You can see in uh, next to me as the picture 1 uh, who the water paper make a process until the recycled paper, and every process, not every process, like um every process have an input and output. So yeah.
Presentation about data and analysis. I'm gonna use the flowchart, and if you guys see in the picture, the first is no paper recycling, and the first is waste paper and pulping the ink, and this stage involves mixing paper with 100,000 kilogram of liquid every day to produce pulp while removing ink. The process yields 110,000 kilogram of pulp. Next is screen pulping. At this stage, the pulp is screened to eliminate large contaminants, resulting in 108,000 kilogram of clean pulp and 2,000 kilogram of liquid waste. The next is cleaning or cyclone stage. This stage removes large pollutant yielding 59,400 kg of clean pulp and 48,600 kg of liquid waste daily. So the next is bleaching. For the bleaching, various chemicals are used to bleach the pulp, producing 63,340 kg of white pulp without generating additional liquid waste chemical used daily. So for the bleaching, we have NaOH 370 kg, H2O2 370 kg, NH2S 740 kg, and fatty acid 370 kg, water 1,850 kg, and white liquor produce 3,700 kg. And the next is sheet formation. The white pulp is modeled into wheat sheets, resulting in 40,939 kg of wet paper sheets and an equivalent amount of liquid waste. And next is drying. For drying, the wet sheets are dried to produce 40,939 kg of ready-to-use recycled paper with 24,831 kg of water evaporate during the process. So for the last is energy use. The total energy consumed is 31,104,000 kilojoules over day. equivalent to 1,296,000 kilojoules per hour or 360 kilowatts. So for the data analysis, it's all, and the next is result. Thank you.
In this section, we will discuss about the mass balance of the production model. And in this table, we can see 10,000 kilogram of paper waste is required to produce 6,827 kilogram of recycled paper as an output. It means this production model has recycling efficiency of 68.27%. And in number 2 of the input, there is 100,000 kilogram of liquid is required in de-inking stage. De-inking stage is used to remove the ink from the used paper that we put as an input. And in this stage, a very high amount of liquid is required. Following that, in the output number 3, there is cleaning stage and there are effluent flow, which amounts for 48,600 kilogram effluent produced as an output. So this de-inking stage and cleaning stage should be improved. The company has been recycling paper waste with many chemicals and discharging effluent. Effluent streams from cleaning, sheet formation, and drying stages together make over 100,000 kilogram per day. It is approximately 94.5 of the total input. So it is being assumed that the liquid effluent is likely to be high. However, in the reduction of COD, the significant reduction in COD from 5,400 milligram per liter to 11.49 milligram per liter demonstrates a very effective treatment. In terms of chemicals that is needed to treat the effluent, fatty acids has a very high cost, so if we can reduce the cost for fatty acids, it will be more efficient in the cost reduction, and the energy consumption is measured at 360 kilowatt per day, and it's within the typical range for the industry. However, we can improve the efficiency of drying and heating process, and in that way, we can make a cost-effective and model. To end this discussion, we have found cost-effective alternative and also an opportunity to reduce the energy demand.
Okay, next, the last conclusion. The correct paper recycling process demonstrates high efficient with a fiber recovery rate of 68.27%. But there is room for improvement through optimizing of the cleaning and the inking stage. The waste treatment system is also effective, significantly reducing COD level, thereby minimizing environmental impact. Although daily energy consumption is considered reasonable, further optimizing in heating and drying process could enhance efficiency. Additionally, controlling fiber loss and improving chemical uses, particularly to reduce the cost of fatty acid, has the potential to lower production expenses. By addressing this area, the recycling process could become more cost effective and environmental friendly. Okay, thank you.